All right, welcome back. How is everyone? Wow, I see so much energy. It's very exciting. This class is amazing, right? I can see you all want to be here badly. So last time we left off, or I guess I tried to argue last time when we met that there's all of these research methods and research strategies that we're going to be learning about, and that they all have their strengths and limitations. There's no, one perfect research strategy that you can always use to answer all your research questions. And we'll be learning about ways in which we can overcome these different limitations of the different methods. Hello, welcome. Somehow the thermostat is fixed, but it is just as warm as last time when the thermostat was broken. Okay, so today I want to hear a little bit about yourselves in your research, maybe what brings you to this class and what you're hoping to get out of it. And we're going to spend the most of the class on talking about how to formulate research questions. So that's the plan. I want to start with just a quick round of intros. I'd like to hear, maybe your names if you'd like to share, or which research topic you're working on. And maybe specifically, I would like to ask you to post in our Slack channel, okay, which is, yeah, can we do that?
What if I haven't figured that out yet?
Well, so it's okay. Just do your best guess at your current research question.
All right.
And maybe you have many research questions. Just pick one. Pick your, I don't know, main research question that you're thinking about the most at the moment. And just post that in the Slack channel. But while we're doing this, yeah, please just tell me tell me kind of what brings you to the class, what are you working on, very briefly, and what you're hoping to get out of this. And don't all go at once. Let's start here.
I'm Manuel. I'm a software engineering PhD student.
Yeah.
Currently starting my second year. Currently, or rather, my general interest is in applying formula verification to distributed systems.
Okay.
Currently, these distributed systems are distributed databases, and yeah, I'm interested in verifying consistency problems that arise in those distributed databases. As of why this course, it's not very clear to me whether this will be directly applicable in my research.
We'll convince you otherwise.
Yeah, I hope so. Yeah, but I'm hoping it will for sure make me a better, at least paper reader, and it will make me more critical when reading papers.
Yep.
And evaluations and whatnot.
Yeah, sounds good. Thank you. Welcome. Marco, what are you working on? Hello, welcome, please.
And Marco, I'm a first year student. My research question is, I was focused on like the fun side of that defense. My question is how we can make those things better. So that includes like learning in between attacks and defenses. How do you like evade defenders of the attacker? How do you learn the latest and greatest, hacker moves quickly, stuff like that. I think that this course is, I'm expecting interest value because there's a lot of things, like from a systems level that you have to evaluate empirically. You can't really do like it's about the behavior of the system and how you can put some methods to seemingly random ways in your qualitative behavior. And on the other side is that there's also some human factors aspect to it, like it's security, and so being able to evaluate like how humans match up to machines or the other way around, how they're put together is going to be very important.
Noted. Thank you. Next.
I'm Hector, so I'm currently a third-year student at S3D. And my common research question is that I'm trying to make a large model for streaming and inference faster, cheaper, and faster. And faster, cheaper is on the system efficiency, and the latter is function efficiency, performance. And how this course is available to me. I think for most of my research, the research method I use is quantitative research, trying to measure the performance and trying to measure the time efficiency and system efficiency using the quantitative methods. And I definitely wanted to explore some other methods to measure my research and my, especially for my domains, and trying to see more research methods. So I think in this way, that's the reason why.
Yep, thank you.
I am from University of Pittsburgh. I'm the first year of PhD, and my research focuses on doing AI complementarity.
Yeah.
Like collaboration between AI or other intelligent machines, how with each other building on each other's strengths, and how the people work together with AI. And I think this was maybe very valuable for me to get to know different kinds of methods as a first year student, and more critical while reading papers.
We're very glad to have you. Welcome.
So, okay. I'm Jeremy. I'm also from the PhD department. So I say PhD
Cool.
student. Yeah, to work here. And my research, my current research question is about like how to break the cycle of the AI disclosure stigma and shadow that. So my primary research option is direction is kind of like the consumer side of like new technology adoption, like for instance, nowadays like specifically for AI. And the reason why I choose course because well, of course, like I firstly know this course by like from a social media platform in China, and there's like a student like promoting extremely well.
I didn't realize we were so famous.
And there's like very few courses like teaching how to do like, for example, set up experiments or do some survey in our school. So yeah, and that's why I chose this. And also like my current project about like breaking this kind of like a circle is start by like setting up for experiments. So yeah, I think this class can like immediately help me with that.
Great, very good. Thank you. Thanks for coming.
Hi, my name is Angel. I'm a first year software engineering PhD at S3D. My current research theme, I'm in general interested in learning how we can use AI to build like programming tools that help programmers to write safe code more efficiently. So this course is valuable to me because I wanted to be able to like understand also from a usability perspective if my tool is usable, and that will involve like setting up surveys or user studies. And,
Yeah. We'll make sure to add enough sort of exposure to experiment design. We already have some later on, but we'll make sure to add more. Good. Thank you.
I can go next. So hi everyone. I'm Anmol. I'm a second year software engineering PhD student. My research is primarily revolving around understanding how AI can support requirements elicitation, but I'm more generally interested in how AI can support software engineering planning, especially when there are high-level requirements and no clear guidelines as to how to implement them. Currently, I'm working on using AI to dynamically manage scripts and requirements elicitation interviews. And I'm taking this class because a lot of the research methods that I intend to involve in my research are motivated in this class, especially conducting surveys, trying to understand statistically whether the observations that I'm making as part of my experiments make sense or
Yep.
not.
Good, thank you. Also because of the room temperature.
Hi, Ganesh. So my name is Prasoon. I'm a 6th-year PhD student at STD department, and
Shouldn't you have taken this class earlier?
yeah, that's so basically my research journey. Even in the last class when we were talking about, I realized that my research journey started other way around. So we started like really precise problems, and now I am, because I have some solutions, I'm trying to figure out what like how can users derive value from those solutions. And so basically my research is on smart environments, like how can we make the physical environments like buildings, homes, or classrooms smart, and what is the value that these smart environments can provide to the occupants of the space. And I'm currently working on how do we solve the needs and how do we navigate the privacy and utility trade-off in these spaces.
Yep, thank you, welcome. Lisa.
Hi, I'm Teresa. I'm a first-year PhD student at S3D. My main interest is formal methods, and I'm interested in providing developers with better ways to use formal methods in their daily challenges. I'm interested in the intersection of LLMs and formal methods, more specifically how LLMs can aid in specification and verification tasks. I guess as a way to democratize access to formal methods, because they may be complex and hard to use. So I'm trying to find ways to make them more accessible for programmers.
Yep, thank you. And welcome. Who's next? I lost track. Did you go?
I'm Yin Hong, and I'm a second-year software engineering PhD student at S3D. And what I'm working on is broadly safety and security for software systems that have machine learning components. So what I actually work on is what proactive things I need to do and how we can make people actually use those.
Yep.
Why do I take this course?
Because your advisor said so?
Yeah. And the other is I do use research methods in those research, and I kind of learn them in a broken way. I want to like learn them.
Good. Hopefully we can help with that. Great. Who did we miss? Bunch of people here. Yeah.
Hey everyone, my name is Sham. I'm a first year S3D PhD student, PhD in cyber computing. I'm interested in studying the impact of AI on software development. So how has Gen AI adoption changed different parts of the software development lifecycle? This course would be valuable for me because I hope that I'll be able to make more sense of the numbers that we see in papers and the numbers I get in my experiments, and also better critique the work done by others who have not been very careful about their numbers.
Everyone else but us.
Yes.
Thank you. Welcome.
I'm Andrea. I'm a second-year PhD student in S3D, and my research is like broadly about using static analysis techniques to better understand robotic systems, and my interest is looking at how the different configurations can impact those systems. This course, I've heard good things about it, so I wanted to take it, and then
I'm sharing your social media.
yes. And then it also, I think, will help me like with experiment design and kind of like what other people have said with like data analysis, like understanding.
Yeah, we will do that.
Hi, I'm Andy, I'm a third-year software engineering PhD student. My research right now is focusing on using formal methods to verify the systems are able to recover after error. And I am interested in this course because right now a lot of my evaluation techniques are limited to doing case studies and benchmarking, and I think it would be helpful to have a broader understanding of evaluation.
Thank you. Welcome.
Hi, I'm Jonesy, and I'm a third year software engineering PhD student
and I'm currently working on programming languages and compilers that help people writing and deploying software on embedded devices. In one of my projects, I want to argue that like certain language features in WebAssembly help developer helps like writing programs on embedded devices, but existing languages don't support it well. So I built a framework to help people writing it, but I realized that it's not really clear for me to evaluate that.
Yeah, it's a common use case for people taking this class. Well,
yeah, I am Shrey, a third-year PhD student, and my research mainly focuses on ensuring software reliability through a number of ways like programming, program analysis, automated testing, and the role of AI in ensuring software correctness. And what would make this course really valuable to me is learning about the different experimental designs and how to make the right claims given certain.
Yep, that's all. It's all about that. So we'll do about that. Did we miss anybody? Oh yes, please, of course.
I'm Mikhail. I'm a second-year SE student, and I've been working on Western engine development, specifically for like Western engines running something like a Python interpreter. So I think that this class could be helpful in like benchmarking performance. Usually there's a lot of like qualitative features and there's a lot of quantitative stuff. So being able to do a good study of that would be helpful.
Cool, thank you. Yeah, welcome. So sorry to disappoint most of you, but this is really not a software engineering class at all. I mean, we will be reading by accident some software engineering papers just because I happen to know them, but it's really not, there's not going to be any software engineering, I think, in this class, except by accident. So hopefully you will enjoy it nonetheless. All right, thanks so much. Is everybody here on the Slack channel? And have you posted at least one research question that you're currently thinking of? Yes? Okay, very good. We'll come back to your questions at the end. Right. So let's talk a bit more about questions. Kind of what does this look like? How does this work? So I'm going to give you tell you some stories of some researchers here. These are, as you can see from the particular interfaces, a little dated. But I think the principles are very much still relevant today, which is why I keep them. So Jane here is a computer science PhD student, and she has this idea that this fisheye view file navigator, that people would use on their computers, is more efficient than the traditional, whatever, tree-based or whatever, folder-based file navigator that you're maybe most used to. So if you don't know what a fisheye sort of UI looks like or works like, you can sort of like imagine a bit from this screenshot. It's kind of like the Mac, toolbar at the bottom. When you hover over, icons, they get bigger. And as you're like moving your mouse or something, wherever you're pointing, that gets highlighted and it's bigger, and so you can read it more easily. Everything else gets compressed, kind of that's not in focus, right? So that's the idea behind this fisheye view file navigator. You could do this anywhere. You could do this in like for file navigation. You could do this for the toolbar, etc. Okay, that makes sense. So that's kind of Jane's starting project here. And the intuition is that traditional file navigation requires a lot of scrolling and a lot of clicks to find the files you're looking for. But if you display the information this way, compress distances, basically, there will be less scrolling. There may be, potentially as many clicks, but there'll be less scrolling because things will be nearby. It'll be easier to, go to the folders you need to go to. Okay. So that's the intuition. So, she's intent on proving the critics wrong, and the critics are saying, look, this is, it's difficult to read because, like, the small stuff is too small and you can actually see it. People won't adopt it. They're used to doing things the way they've been doing them forever, and you're introducing this thing which is radically different. It's just never going to work because it's so, different, even if it's a good idea. and maybe other things that they criticize. So Jane would like to collect some empirical evidence to support or refute her intuition that this is a good idea. So let's start from the obvious. What might Jane's research question be? Write one down. Based on my description, just formulate Jane's research question, and I'll leave the description back up for a second. Just one research question. What might Jane ask? What's the most obvious question that she could ask based on my description here? Write one down. We'll come back to this. Imagine you're Jane. Formulate, articulate a research question. Anywhere. Yeah. You don't have to put it on Slack, but just write it down somewhere so you can remember it, and so we can discuss it in a minute. In your notes is fine. Anywhere you want. I guess side note, any research project you start usually starts with some overarching research question or set of research questions that you're hoping to answer. It's usually the case, at least if you're doing things right, that the questions come first, and then you do all the work, and then you write the paper, rather than do all the work and then retrofit some questions onto the work that you've done already, which is also something that may happen in practice. But that's not, do what we teach you to do, not what we happen to also do ourselves sometimes. So, research questions always come first. When you're designing a research study, you start by asking the questions, and then you design a study that would answer those questions. Right? We have something? Okay, good. Okay, what questions do we have? Can I hear just a couple of examples? Yeah, please.
What file developers do?
Okay.
Does the fisheye navigator improve efficiency?
Yeah, that seems very obvious given my description, right? Yep. Any other examples?
How does fisheye file navigator affect scrolling behavior?
Okay. Anything else? Annie?
Are users able to more rapidly find specific files in the fisheye viewer compared to a standard viewer?
Cool. Yeah, thank you. Anyone else? Anything different?
What sort of learning curves do users experience with the fisheye file evolution?
Okay, so you're even going beyond the specifics of, I don't know, the narrow goal I outlined on my slide there. Oh, good. Anything else? Something different that we haven't heard? The rest of you had more of the same? Okay, all right, so we'll come back to this in a minute too. So now, for a contrast, meet Joe. Joe is also a PhD student. Joe is interested in how engineers, software developers, use or not a particular type of design drawings. I don't know if you've ever, software engineering students may have heard of these UML design diagrams. This is really not the point. It's not relevant for the case study here, but imagine there's some formal notation or whatever to draw architectural diagrams or whatever diagrams of a software system that you're working on implementing or something like this. So it's a design language for software. So there was a time when all software engineering students were taught this in courses. I don't know that that's the case anymore. It's I don't know, fallen out of fashion. But professors were recommending this specific UML language that was used for this kind of design diagramming. But Joe, who interned at Evil Core the previous summer, noticed during his internship that this specific thing that the students were taught in class was hardly ever used in practice at the company where he interned. Okay, so that's the context. So now his research goal for this project is to explore how widely used these particular types of diagrams are in industry and how they're being used during or used as collaborative shared artifacts by engineers or whoever on these teams during software design. So that's the research goal. What is Joe's research question? Write one more down. Here, I'm going to put this back up so you can. Any examples?
How popular are viewable diagrams in industry? What tasks or purposes, like collaborative shared artifacts, are they used for and when?
Okay. Lots of questions there. Thank you. Anything else?
What are the values that developers find in using UML systems?
Diagrams.
Sorry.
Yes. Thank you. Yep.
How tightly coupled is a UML diagram with the actual evolution of a coding project at the time?
Wow. So much beyond the sort of narrow description here of the case study. Yeah, it sounds good. Anything else? Yep.
So in which scenarios where the UML diagrams are widely used for those people who's frequently using?
Yeah, good. Anything?
Looks like the gap between the academic setting and the industrial setting, in terms of the software design tools being used.
Meaning, why don't they use these things that I don't know, students are taught in class or something? Right. Any, yep.
Does the size of the team or the company affect how, if they use UML?
Okay, yep. All right, great, thanks. Lots of good questions. Okay, so let's look at a few specific ones. This may have even literally been among the ones you mentioned yourselves. So let's start with Jane. Is a fisheye view file navigator more efficient than the traditional view for file navigation? Let's say Jane had asked this research question. What's wrong with this question? What would you change, if anything?
Like, what's the definition of like more efficient? Like, how do you determine that?
What does that mean? What does efficiency mean? Yep. Please.
It's not very precise. It's like a yes or no. I would say like to what extent.
Okay, so because is something implies a, I don't know, yes or no answer. And to what extent implies a, I don't know, numerical answer or whatever. So some sort of more fine-grained answer. Is that the idea?
It's qualitative, but it's more than yes or no.
Okay, yep. Good. Marco?
What is the traditional view of navigation?
Okay, yeah, so there's some built-in assumption here that we understand what that means. I don't know, maybe earlier in the paper, there's an explanation of that, right? Yep.
It's better to set scope more precisely. For example, if it's for programming or for like daily tasks.
So for what tasks you mean, right? It's like file navigation, like when and for what purpose, right? Maybe that's important. Right. Good. Anything else? Thoughts on the questions? Feedback on the question?
So if the goal is to collect the evidence to support or refute the critics, one of the questions that critics argue is that developers won't adapt. And I'm not sure whether this question like have anything that talks about that how difficult it would be to move from traditional systems, whatever they are, to fisheye.
Right. So there's more to Jane's research program than just the question, is essentially what you're saying, right? So this is part of the research program. Tries to do some comparison between this new approach and I don't know, the existing predominant approach, but doesn't focus on deployment in practice and how to do that and so on, right? It's sort of
Yes.
Yeah. So what I'm saying is there's more to ask, right? It's not the only thing that Jane could ask.
Yes, I mean, if the goal is to collect evidence that support or refute what critics are arguing, this question needs to be reformed. Exactly what you said.
Right, but what I'm saying also is she probably also needs something like this. Or she needs to demonstrate somehow that this newly proposed approach is better, quote unquote, than the old one. But you know, even if people don't adopt it, right? At least you need to know that it's better.
Yeah, this should be the first question.
Separately, you worry about how do you get them to adopt it. Yeah. More feedback on the question? What about Joe's? How widely used are UML diagrams as collaborative shared artifacts during software design?
What is widely?
What is widely?
Like, is it out of 10 tasks that the company does, 2 of them use it versus for each task, what's the proportion of people who use it?
Mm-hmm.
No, I like that idea of like, it doesn't say like percentage of companies that use it, or like out of all the companies that use it, how much do they do it, or there's not really a good structure around. Like, okay, maybe like 2 companies use it, but it's Google and Amazon and they use it for everything, versus, you know, everybody that is kind of at a smaller team level or something like that. Everybody uses it, but then Google and Amazon don't.
Okay, so you know when, by whom, under what conditions, that sort of thing. What else?
The assumption here is that UML diagrams are used as collaborative shared artifacts, but it might not be the case in every industry. Some people might be using them, but they're not like collaborating and discussing those diagrams with one another. So that might be something wrong with the question.
Maybe what is collaboration?
Yeah, what's collaboration? What's a collaborative shared artifact? Yep. Anything else?
What part of the design process, or like what counts as the design process?
Yeah. Oh, yeah. What counts as design? Super strong assumption here, right? That we, I don't know, agree on the meaning of this thing, right? It's like anything can count as design, right? So what's the scope of this question? Is it formal design? Is it informal? Do you need a whiteboard? Do you need a team? You know, do you do it individually? Like, is it the initial design? Is it later design? Whatever, like a million assumptions, you know, hidden behind this. Speaking of, what other assumptions do both of these questions have behind them? What are hidden assumptions here?
The first question kind of believes that fish IVU is better. Is that what you mean? Like, you'd only do a study like this if you want to, and frame like this, is it more efficient?
Yeah, I mean, yes, I gave you Jane's intuition for why she believes this. Yeah. So you believe this is better, right? You're trying to show this, but yeah.
Related to that, I feel like there's like an assumption that there's an efficiency problem with the standard file navigation system.
Great, right? Like, what if there's nothing wrong with it? Yep. Absolutely strong assumption. What else?
The assumption that UML diagrams are actually being used.
Or should be used. Yep.
And also the fact that they're used in the industry is also an assumption, because the question doesn't say industry at all. It says like how widely they're used. So the scope in which these diagrams are being used is assumed in the question.
Right. Yeah, I guess in the scenario as I described it previously, it talked about industry.
Specifically industry.
Versus academia.
Yes.
Yeah. But that's right. In just the question itself, there's this assumption that we're referring to industrial use. Yep.
For Gene's question, it feels like answer can be, it depends based on who is using the file navigation? Like, if there's an assumption, there is a clear answer, maybe that yes, it is efficient, or no, it is not efficient.
Yep. So the questions are vague. There's sort of a kind of fundamental problem with maybe both of them, because they hide all of these assumptions. Any other assumptions? I don't know that there are. I'm just checking. I mean, yeah, I could, for example, shared artifacts and collaborative design. Again, assumptions, like you're ranking all kinds of assumptions about the process. You know, what if people do a lot of design, but they don't do it collaboratively? Or what if they do a lot of design, but they don't share artifacts? So, you know, just all kinds of assumptions about the process, right? That sort of, you know, maybe forces you to look very narrowly at the wrong thing ultimately, and kind of, you know, miss the forest for the trees sort of thing. You know, with Jane, big assumption is that traditional file navigation is problematic, is inefficient. All right, so here's a few more sort of comments on all of this. I guess the meta point is that, you know, maybe the first question that comes to mind is not always the best question to start with, and it's maybe worth, you know, spending a minute or two reflecting on what it is you're asking, and what an answer to that question would look like, and even if it's possible, kind of before proceeding with designing a study. You know, because the risk is you design a study that ends up answering the wrong question potentially, and you know, you will have wasted months of your life or something by then. So yeah, a bit of reflection early maybe saves you a lot of time later down the line. So here's some comments. For Jane's question, do we actually know that, you know, people need to do file navigation, and when do they need to do file navigation? Under what conditions, and who needs this? Like, who is it that does everybody need this? Does, you know, some people rarely need this? Does everybody always need this, etc.? Right? Do we know that? What does that even mean? Like, what does file navigation mean exactly? You know, what counts as file navigation? Does search count as file navigation? You know, like, what's the scope of, you know, this particular activity? What does file navigation mean? When, you know, and under what conditions do people do file navigation? Is efficiency really a concern? Are people sort of, I don't know, bothered by this activity? Is efficiency a concern that's currently inefficient? And then what does that even mean? Like, how do you measure efficiency? I think, Andy, you had speed or something. You sort of had a very concrete way of you know, thinking about this. But when you ask efficiency broadly, what does that mean? Like, does that mean faster? Does that mean, you know, fewer clicks? Does that mean something else? You know, it could mean lots of things. What does that even mean? For Joe, right, what's a collaborative shared artifact? We mentioned this before. Like, does that even exist? Do people work like this? Is that part of the process? Can we find one? Can we identify one? Would we know one when we see one? Like, what does one look like? Could we identify and measure them? Could we even say which things are and aren't UML diagrams, right? What if you don't strictly adhere to the official formal syntax, but draw something that looks kind of like it? You know, does that count? So, like, can we even say what that means? What's really an UML diagram, right, for the purpose of this study? Right? And where do you draw the boundary? So both of these questions are vague because they make all these assumptions about the phenomena to be studied and the kinds of situations in which the phenomena occur. So here are some possibly better questions that Jane and Joe could have asked instead of the original ones we discussed earlier. So they could ask exploratory existence questions. This is sort of a very, you know, if this is a new phenomenon that needs to be explored before you design solutions and build tools for it, that's very reasonable to start with existence questions. Is file navigation something that, I don't know, certain stakeholders actually do? Is efficiency actually a concern? Do these collaborative shared artifacts actually exist? Right? How frequently does that happen? You could try to describe and classify the things you're exploring. How do we measure efficiency for file navigation? What are the different ways of doing this? What are all the types of collaborative shared artifacts? For example, I visited Google a couple of years ago, and they were big on design documents. So, people would write textual design documents in literal Google Docs, and that would be a collaborative shared artifact that they would use to design something right before they would build it. In my experience, I haven't seen people drawing UML diagrams at all. I think they may be drawing other kinds of figures to illustrate what they were doing. But there's lots of types potentially of collaborative shared artifacts that people may use for software design, for example. So you may want to understand what those are before you focus on this particular one that maybe is not very common, maybe it's not very useful. You could think about comparative questions where maybe you want to understand how this newly proposed fisheye view differs from conventional views. How do UML diagrams differ from other kinds of representations of design information, like textual documents or whatever else, and so forth. So these exploratory questions are usually very good when you have a new phenomenon in general, or you have a phenomenon that you yourselves or the community hasn't studied much and that is poorly understood, because they help you arrive at this clear understanding of the problem of the phenomenon. They help you define things more precisely. They help you understand what evidence you would need for measuring them and how to collect it. They might give you some evidence that your measurements are valid and so forth. So it's very common to start sort of with exploratory research at the beginning of a research program. Yeah, great.
These questions are questions that one should ask themselves, or are these like exploratory research questions?
Yeah.
Because I think very important to understand how is the question how to fisheye views differ from conventional views. Like, what's the goal of that question? The definition of fisheye view is the information.
Okay, so this is a great question. There's lots here. So let's unpack for a second. Two questions, I think, hidden in your question. One is, when do you actually ask these questions as part of your research program or project, versus when do you take them for granted, in a way, right? So you just, assume them or leave them be or something. The second question is, more specifically, like, why would you ask something like, why does fisheye view, or how does fisheye view navigation differ from the traditional view? Why would you ask something like this? So let me start with this one, because this may be a little more easy. So the question, the reason why you would really want to understand fundamentally how these two things are different is because ideally, all of the research that you will do will operate at this sort of conceptual level. So the risk is that I come next and I propose a third file navigation mechanism still, and every one of you comes and proposes a new one still. So it's not productive to have us run 20 sets of experiments or pairwise combinations thereof to see which one is more efficient. It's much more productive to try to reason about all of this at one level of abstraction higher, at the level of concepts or sort of theoretical level. So in that sense, you would like to understand fundamentally what is different between fisheye file views navigation and the traditional one, so that when you see more instances of the same theoretical constructs, you can expect the same behavior, meaning you can make predictions about improvements in efficiency or whatever else, the things you care about making predictions. You could make predictions just based on this understanding of this theoretical mechanism, rather than having to, again, empirically test all of these one at a time. So it's really very useful to be able to understand what the theoretical mechanism is behind the phenomenon you're studying so that you can make predictions. Because otherwise it's just, instances of, individual instances that all superficially look different. That's just not productive. So that's one. Does that make sense?
Yes.
We'll actually talk about theory, I think, soon, maybe next week. This is kind of that direction. Like you really would like to, right? So this happens a lot, by the way, in software engineering, this happens a lot because people build tools or algorithms or whatever. And, there's this expectation, right, that you compare to all previous approaches empirically to show that your tool is somehow better than the previous ones, right? So then, more people build more tools and, this expectation that this set of comparisons grows, right? That's not productive. It's not, a good way of doing this. I think a much better way of doing this would be to reason about the fundamental properties of the tools that are different and the mechanism through which they could explain the differences in performance of the people using the tools or whatever. So that when you see new tools, you reason about them in terms of these theoretical mechanisms, not in terms of, instances of. So that's kind of that. The other one, you're asking, like, when can you assume things versus when do you have to study them yourself? This one's hard. I don't think I have an answer to this. This comes up every time I have this discussion with students. So I mean, the easy answer is some of these may be covered in the literature in prior work. So in that case, you're fine. My personal take on this is, some things I just find more interesting and I would like to focus on more than others. I think that's okay, but just make explicit, the least you could do is make explicit the assumptions you're making when doing that. Right? So you're saying, like, look, we assume fundamentally that, this thing happens and, that people care about this and whatever else, we're not testing that as part of the study. We're focusing on something else, right? But really, we don't know, right? So we assume this, we don't really know, right? So, if you actually want to be more rigorous, you should probably go and test this empirically too. So I think that, that's my pragmatic take to this. But I don't have a satisfying answer. I think normally you would do them all, but that's just not feasible.
Like for example, there were a bunch of papers on agents, even before the papers defined what agent is. And those came later. There were a lot of papers on vibe coding, how useful it is. And then later on, some papers define what vibe code.
Yeah, so I mean, usually papers that, I don't know, take a step back and reflect and kind of add clarity of thinking to some murky area, I find very useful. It's worth writing those. I enjoy reading them. I think it's worth writing them. So if you get a chance to write papers like this, where you add clarity to otherwise mess in your research areas, that's probably a good idea. Okay, anything else here? Okay, so here's a few more kind of going from exploratory onwards. You could ask frequency and distribution style questions. How many of these things are created in large software companies? You could ask questions about the process. How do programmers navigate files using existing tools, right? You want to describe the current process, understand it before you think about ways of improving it, right? Maybe you're making all kinds of, when you propose this new file navigation mechanism, you're making all kinds of assumptions, like we discussed earlier, about the current process people are following to do file navigation in practice, right? Why don't you go study how they actually do this thing in practice, right? To make sure you're at least, proposing improvements to something that they're actually doing. Maybe they're not doing the thing you assume that they're doing, that you're trying to improve, right? So, your improvement will have no chance of succeeding in practice because they're not actually having the problem you assume they're having. Right. This is so frequency-based questions are also very useful because they give you a sense of how typical or atypical, common or uncommon a particular thing is, especially useful for problems, right? So, if a problem is real, but it's only experienced by one engineer out of 100,000 at a company like, I don't know, Microsoft or something. Maybe it's not the most important problem you could be working on, right? Maybe you should be working on a problem that lots of people are impacted by. So kind of understanding the scale of a problem is very useful for motivating that you should be working on it. Next one up, and so this transition from exploratory to, I guess, hypothesis testing is asking questions about relationships. So, for example, does efficiency in file navigation correlate with the engineer's familiarity with their programming environments? In other words, is file navigation really the problem? Or perhaps is lack of familiarity with just the tool they're using the problem? Right? So if you just let people, learn how to use whatever tool they're using, maybe they become very efficient at it. You don't need to change the file navigation mechanism, right? Maybe the problem is actually lack of familiarity, not mechanism for file navigation. So studying these relationships, and some of you have asked about this earlier, would be a way at kind of getting at the contingencies behind this. Or, for Joe, do managers' claims about how often they use these UML diagrams correlate with the actual usage of UML diagrams? These days, all the managers in industry are pushing down AI tools on, engineers. Does management's push top down of AI tools or AI adoption, does that actually mean that people are adopting and using these tools, day to day? That's sort of a very relevant, timely, useful question to try to ask and answer. Right. So these get at correlations. So you want to establish empirically that something is co-occurs or it's related to the occurrence of something else. And next one over, this is where you're getting at mechanisms. This is where you can start to ask causal questions. Do fisheye views cause an improvement in efficiency for file navigation, assuming we agree on what efficiency means? Any feedback on this question? Kind of related to my previous comment earlier about, I don't know, mechanisms. Why would you be dissatisfied with this question?
Someone answering what efficiency is.
Let's assume we agree on that.
Comparing to what?
Traditional mechanism. Valid points, all of these, but not quite. I think the most offensive thing is something else, personally. Other thoughts?
Or like during what task?
Not that.
I mean, it makes it sound like it's a 100%, like it causes an improvement no matter what.
Let's say we can even measure the extent to which it does.
Mine's kind of related to that. I was thinking of it as like the issue with the cause versus like observing a trend or something. Like, is it?
I mean, cause is good, right? Causal relationship is the best you can hope for because it means you can make predictions. So it's the ideal thing you could do is make causal claims and establish causal relationships in all areas of science. Think medicine, right? You want to be able to claim that some particular medicine or drug or vaccine or whatever causes the improvement in a disease, right? Like you really want that. That's ideal here. But I'm saying that's really unsatisfying for some.
Because it probably does not talk about what leads to the improvement.
That's it, right? So, I normally talk about this when we talk about, I don't know, experiment design much later in the class, but since we're on this small rant, you know the story of scurvy? Have you heard this before? Does anybody know what scurvy is? A disease that's caused by? Right, vitamin C deficiency. So turns out that they proved in a causal sense through a proper experiment in maybe the 1700s that lemons cures scurvy. And this is maybe the earliest recorded randomized controlled trial in the medical sense that we think of today. I don't remember the names of the people involved, but it was essentially what you would think of as a modern randomized controlled trial where they gave sailors that had been at sea for a long time, actually a bunch of different things. They tried, I think the working hypothesis was that it's sort of sour or bitter things. So they tried, I don't know, pickles and lemons and I don't know what else. A bunch of these different things. And they've established causally that, you know, lemons were it. Okay. So this is as gold standard for science as we've ever had in terms of, you know, a good experiment design, in the sense that you established this causal relationship between lemons and the disease or lack thereof, right? Which means, right, that you can make predictions, right? So next time you see people getting sick with scurvy, you know, give them lemons and they, you know, you cure them, right? So the having established this causal relationship is super powerful because it allows you to make predictions, which allows you to, you know, treat people and so on, right? Great. But it took them about 100 years, if I remember correctly, maybe 80 years or something, right? It took them 80 years from this realization until they actually understood the mechanism, right? They had established causally that, you know, lemons cure scurvy, but they had no idea why, right? They thought it's because it's sour, not because it's vitamin C. Okay, so to the point here, right? This question to me personally is very offensive because it does not go after the mechanism, right? Even if you can causally establish this fact, right, which you can with a good experiment design, for instance, right? Even if that's the case, but you don't really understand the mechanism, right? That's not as useful. It's not satisfying. I find this very, you know, unsatisfying personally, right? I would much rather understand why this is happening, right? Why is it that fisheye file view navigation is, you know, 2 times more efficient under some definition than the traditional view? Like why? Why is that? Because then I can use that mechanism somewhere else and make predictions, right? I can reuse the mechanism because the mechanism is more generic, right? Than the particular instance of this fisheye file view navigation. Marco.
My question is, let's say you're studying like, I mean, let's go back to like the scurvy example thing. I'm a doctor and I'm giving out these lemons, and I mean, it seems like first, you know, you have no conception of the mechanism behind why these lemons are helping. Beforehand, if you were to do some work into like the mechanism of the lemon, quote unquote, that would be separate work on its own, right?
Cool. Yeah. Yes.
That wouldn't be like, I'm going to list out all my assumptions about the mechanism first, and then this is like really two things that like two problems in one that I'm completing.
So I guess what I'm saying is, you know, if you design an experiment to test some hypothesis, you know, in this case, that this particular type of navigation is more efficient, whatever that means, than the traditional one, it would be better if you design an experiment to test the mechanism behind your new thing rather than the instance of your new thing. So you know, people sometimes refer to this as you test the theory, not the tool, right? Test the mechanism behind the instance of the tool you've built, because the mechanism is much more generic and applies to all the tools, right, that use the same mechanism, right? Nobody really cares about your particular instance of, whatever it is, but, everybody will care about the mechanism because they can reuse it somewhere else. So I think design studies in such a way that you can test the mechanism, not the instance of it, is the lesson, I think. This is, by the way, really, if you can remember one thing from today, this is a good thing to remember. Like go after mechanisms, not the surface level stuff.
So would there be any value if we say that is there a correlation between the improvement in efficiency of file navigation when people use fisheye?
Huge value, right? I mean, if not just correlation, causal relationship, huge value. If I can causally prove that a certain vaccine, I don't know, prevents an epidemic or something, right? Ultimately, who cares why that happens? Right? I mean, the value of curing a disease, right, is enormous. So even if I don't understand why it happens, huge value in actually being able to make predictions about it. But much more satisfying still if you know why it happens, right? Because then you can reuse the mechanism. Yeah. So it's by no means without value. I'm just saying you could do better. That could be huge value. So all of these engineering things, by the way, so big software companies operate at huge scale. They have 100,000 engineers and whatever, huge engineering efforts. So and lengthy processes and whatnot. So any small improvements in anything in such a context as large scale industrial engineering will have huge practical impact, right? You will make them or save them a ton of money, right? So even if you don't understand why, by the way, so speaking of, all of these web-based companies run A/B experiments, right? So I don't know, like a different shade of green of some button, right? That makes you click on it more often, right? Ultimately, they have no idea why you are more likely to click on this shade of green versus that shade of green, but they also don't care, because they make $100 million more by selling you ads or something, right? With one shade of green over the other. So the mechanism there is, like they may just not care, but it could have huge practical value.
You keep asking why all the way down.
When you stop, or
Yeah.
I mean, I don't know. Like I personally stop in the domain as sort of domain concepts. I don't know. You go down to atoms ultimately, and electrons and whatever. I don't know that that's useful. So problem domain is where I would stop.
Yeah.
Personally, but yeah. So remember this thing, like why? Like ask why. And why is it that you would expect your thing to be better than the other person's thing? Why? Right. Okay. Right, comparative. Right, so this is slightly better because you have a reference. So you mentioned this earlier. We didn't specify what the reference was. Okay, yeah. So look, this is becoming even more interesting because it's getting at the contingencies here. Right? So when and so this question here, is this does this cause programmers to be more efficient when they're distracted but not otherwise? Right? This already hints at the mechanism, right? It shows that you have some understanding of the mechanism, at least some hypothesis for the mechanism, right? Because you're able to make predictions in a particular context and not in others, right? You're sort of it shows some understanding of the underlying mechanism, why this thing works, that allows you to make targeted context-specific predictions. So stuff like this is always good. Yeah. Okay. And finally, let's say you have established causal relationships, which is great. You can start asking design questions where you start building tools and solutions and whatever. Even if you don't understand the mechanism, but you can make predictions causally, that's already enough for this purpose. Right? You can start building solutions. So maybe what's an effective way for teams to represent design knowledge? Right. Okay. So I guess the idea is that a long-term research program, certainly over the course of your PhDs, in any applied discipline like most of ours in computer science, unless you're doing theoretical CS, most everyone else will do applied research, typically involves a mixture of both exploratory so-called knowledge questions as well as design questions, which is sort of building solutions or something and testing those empirically. So you will likely cycle at least once, maybe multiple times over the course of your PhD, certainly multiple times over the course of your research careers if you stick to doing research through these types of questions. Okay, so now let's go back to the questions that you wrote down for Jane and Joe. Is there anything you have learned since that would help you rephrase, reformulate the questions you had originally asked? Had you already asked great questions? Maybe a short moment of reflection here.
So the questions that we were criticizing earlier, and then you showed us a bunch of questions.
Yeah.
A lot of those criticisms apply to these questions as well, right?
Definitely.
Which makes me think that it's not the issue of the research question, just that it's a broad idea. We have just read the title, but not like the proposal where every detail is mentioned. Right?
So say again.
So basically, all the things we criticized are technically things we should think about
Correct.
before we do execution. But research question is usually like a broad abstract research question, right?
Well,
the rest of it is details of threat.
I'm not sure. I'm not sure I agree. A vague research question that is not answerable or is answerable in multiple ways is, I think, of little scientific value. A precise research question that's clear and does not make implicit assumptions and so forth, I think is of much higher scientific value in that sense. What about your own research questions, the ones from the Slack channel? Any volunteers? Anybody brave? So could you share your original question and how you might reformulate it now that we've had this discussion?
So the question that I asked, I think I left a little bit particularly vague, even at the beginning, which was how can we make cyber or autonomous cyber attackers and defenders better, quote unquote. The work that I'm doing right now is making like a benchmarking framework for to see like the empirical measurements on how it's turning out. So then the question for that then would be something, I mean, this is like you're building up the infrastructure around the mechanism itself, right? Where you see the beginning of the input and the output, not really seeing the mechanism between, but it's a way to evaluate. So this would be like, what are valuable metrics for cyber attackers and defenders who measure success, maybe, or something like that.
The one possible question out of maybe a set of questions that you would have to ask,
Yes.
on this research program. Yep. Anybody else? What the question you wrote in Slack versus how you might reformulate it now, if at all. Everybody had perfect questions?
My question was, how does AI adoption impact software development practices? I think one of the assumptions here is that there's a well-defined set of software development practices. Maybe the first thing is to better understand the different ways in which software development happens in different places.
And then what does AI adoption mean? Is it one particular tool? Is it all tools? Are they all the same at one time? How often, by whom, right? All of these. Anyone else?
The question, but when you teach this class and when students give you the answer to this question, does it feel like your child like showing you a poster of like a drawing that they made?
I struggle with this myself. I'm more sensitized to it now because I've sort of I don't know, been on the giving and receiving end of this discussion myself. But I mean it's hard for me too. It's sort of
It's not an easy answer, I guess, to the question, or like if it's not an easy way to approach it to achieve this.
the high level bit is the first question that comes to mind is not always maybe not often the best question you could ask. So in that sense, again, like just a bit of reflection on what it is you're asking, what it is you're trying to answer, I think would go a long way towards improving a research program or a research proposal or a thesis or a paper or all of that. So that's kind of the message for today. Let's me do something else. Remember the discussion from Tuesday of these maybe two predominant philosophical worldviews, the positivists versus the social constructivists? Kind of, reality is this objective external thing that's observable and whatever, those were the positivists versus, reality is a social construct, were the constructivists. Is Jane, with the fisheye file view navigation, is Jane a positivist or a constructivist? With the questions she has been asking, that we've been discussing.
I'd say positivist, just because it seems like she assumes there's single way that will make all developers more efficient, and it's not dependent on like personal circumstances.
Anyone else? Valid interpretation. Does anybody think she's a constructivist? Really?
She could be right, because there is no single truth of what a file navigation system, what the best file navigation system is, and different people have their own realities of it.
Yes. So I think that's another part of the message here, is that she could be either or both. I don't know if at the same time, but certainly both. If she were a positivist, which she could be, she might want to run a controlled experiment, in a lab setting to demonstrate causally that her file navigation mechanism is superior to the traditional one, and she would only accept such experimental evidence from a controlled study as proof that her solution is better. If she were a constructivist instead, she might just say, look, these lab experiments are useless because they're so constrained and so artificial that they abstract away all of the real world messiness that actually matters for stuff like this. Like in a lab setting, it's too artificial. This tasks and context and whatever that you're able to observe in the lab and short tasks within a limited time span, etc. It's so unrealistic and unrepresentative of what people do in the wild. So it's really, there's no point in doing any of this, right? What you should be doing instead is something like field work or an ethnography or something. You should be observing how people do this in practice and thinking about all of these contextual factors that have an impact on their performance and whatnot. So she could be both of these people, and actually it's probably useful if she were both of these people. I think there's value in thinking in both of these ways about this problem. I think you certainly would want to show empirically that something works, at least in a lab setting. And certainly you would want to understand sort of the real world deployment, world context for making that scale out of the lab. So I think, I guess advice would be to be a pragmatist here, be both a constructivist and a positivist, and try to get at this from all angles. Okay, so this is probably a good time to end. You will find on the deck some examples of questions that you could think about, how might you design studies given these research questions. I won't make you do that now. I also have pointers to 2 papers. You're welcome to read these. They kind of ask fundamentally the same question, but from very different perspectives. So just to give you a sense of kind of how differently people can think about the same fundamental question or fundamental problem. So just some examples here. We won't do this now. There will be shortly a lit review homework. So I'm going to ask you to do a lit review on a topic and write up a page or something about this. We'll release that ASAP. We're working on fine-tuning it, and we'll release that very soon with Claudia. And otherwise, I'll see you on Tuesday. I'll also send the reading list so you can sign up to present some papers. There's some, I guess, benefit to people who volunteer early because, maybe they will be spared later on as you get busier with the semester. So good to do that. Have a good snowstorm. I will see you next week.